Hello there, this is Benjamin from Eclipse, today with my colleague Ian, as usual, for our IoT Hangout, 11th edition, I guess, right?
Is it
Ian?
11? Wow,
Yeah,
we're getting up there. So
I kind of
welcome,
stopped
Ben.
counting, but whenever I create the event, I try to announce that it is the 11th, 12th, whatever. So anyways, today we have Michael Koster from Harm, and we're going to actually talk about something that's been announced just a couple of weeks ago, I think. It's called IPSO Smart Objects. So, Michael, what is IPSO Smart Objects? I think this has to do with lightweight M2M at some point, and basically it helps to model IoT objects. Is that correct?
Yeah, that's basically what IPSO objects are, an object model or a simple data model for IoT objects. And the connection with lightweight M2M is that an IPSO object follows the same URL template pattern as a lightweight M2M management object. So with IPSO objects, you're able to register them and interact with them using a lightweight M2M client and server, but using the lightweight M2M server now as an application server. So IPSO objects allow you to extend the basic URL data model of lightweight M2M to application objects. So, for example, we published a guideline with 18 objects, and the objects are things like a temperature object, a pressure, barometric pressure object, an accelerometer, a magnetometer, things like that. And then out of those simple objects, you can build more complex APIs to actual devices that have multiple sensors on them and actuators.
And so how do you see people using, like, who's going to use these objects? So is it a developer or a device manufacturer? Or?
Right. So the main idea behind this is basically to use the standards that already exist in IP protocols, so that's CoAP and lightweight M2M, to provide application-level interoperability between devices and applications. So using this object templates, a device manufacturer could manufacture sort of IPSO smart object-based sensors and actuators for, say, for example, a smart home, and then people writing applications could write applications to this. Would be the API to the sensor. And so even through the lightweight M2M server layer, whether you're interacting through lightweight M2M or peer-to-peer or between the smartphone and the object directly over CoAP, the URI patterns are the same and the discovery mechanisms are the same. So any application can interact with any sensor. That allows you to put new sensors into an existing a smart home, for example, in the system, and interact with software that's already managing the existing sensors and actuators. And it also allows someone to write an application and deploy it onto existing sensor installations.
Interesting. Okay, so basically, the device would come with the way they publish their API is through a smart object, essentially.
Exactly. In fact, a smart object is almost a self-publishing API. It contains enough. If you have the pattern encoded in the client, which is a reusable pattern, a pattern of reusable objects and resources, then that client can basically discover smart objects and already know how to interact with them based on the semantic information in the pattern itself. So, for example, the temperature object has a code that identifies it as a temperature object, and then resources within that temperature object have codes that identify them as particular attributes of that object. For example, the current measurement value, or the highest measured value, the lowest measured value, the application type, string tag. You can say this is my living room temperature sensor, etc. Right? So those are all encoded in the object and resource IDs, such that a client that knows that pattern then can understand any object that follows that pattern.
Yeah, so basically, I guess because of this kind of very of this contract of how the attributes look like, it's then pretty easy to have any kind of lightweight protocol to actually exchange the data. The metadata is already agreed upon, right?
Exactly. So it doesn't really depend on using CoAP protocol or lightweight M2M. The IPSO objects themselves are just URI patterns. They could be used over HTTP, or they could conceivably be used as MQTT topics, for example. And there's nothing that would stop you from using that same object pattern, because it's sort of free understood at both ends. And the discovery, well, with MQTT, you'd have to sort of subscribe to the whole resource and get the whole complex data type back if you wanted to do discovery. But you could certainly connect to individual resources and get updates. The whole concept of lightweight M2M based on CoAP notifications, asynchronous notifications, is that you can subscribe to an endpoint just as well as do a get or read in a RESTful fashion.
So say I have two temperature sensors from two different vendors. Do I need two different instances or two different smart objects themselves?
So that would be two different instances of the same smart object ID. That's
okay.
Part of the pattern is multiple instances.
Okay.
So any number of instances. For example, a washing machine might have 6 or 8 different temperature sensors for different things that are happening. It might have a motor temperature sensor and an inlet water cold and hot and cold feed temperatures,
right.
etc. So those would all just be multiple instances that would have application type tags of what they actually did in the model.
Okay, so but the assumption is that all the washing machine vendors have come together and said, yeah, this is the common format that we're gonna. These are the fields that we want in the instance of a washing machine.
Exactly. Well, different vendors could have different sets. For example, one vendor could just offer the inlet feed and the tub temperature, and it could be an enhanced feature to offer more sensors. And
right.
the basic client would still work with both. It's sort of a web-like pattern, like a browser. A web browser can interact with different levels of web services based on what they provide, and in the same way we want clients and applications to be able to interact with the basic level or the more, the maintenance application would need access to the motor temperature, but the consumer application would only need to know that the motor's overheated so the thing's not running right now.
Right. So can you, how do you, I don't know if you, can you show us how you create a smart object? Like, do you have can we bring up a documentation that we could look at, or what does a smart object look like, and how would somebody create?
Okay, so let's see. What can I do here? I can share my screen.
Yeah. Just
let's try. I want to make sure there we go. Okay, so let me just get down to what a smart object is. Here we go. So here's the URI template for a smart object. It has an object type, in this case 3303, an instance 0, of which there can be one or more instances, and then a resource ID within the object. So basically this is what an example of a temperature sensor, and this is a fairly simple temperature sensor. It's a recognized. The 3303 is a registered type. It's registered with the OMNA through OMA. This is a registry of object types that are well defined. This is one of the first 18 that are currently registered. And the resource IDs are registered also, so they have well-defined meanings. Their sensor value, minimum and max measured value. These are just 3. The sensor value is mandatory. The other 2 are optional, and there are some other optional, like minimum and maximum scale values, the min and max that the sensor can actually measure. And there's a reset resource, and there's to reset the min and max, and there's a application type and sensor type tags that can be optional resources also. And then you're free to add as many resources as you want to your own instance of a sensor. This is just a guideline for you know, for a base configuration.
Right.
You know, so there are all these reusable resources. So here's some more examples. Here's like the Bluetooth low energy heart rate sensor turned into an IPSO object. So that application profile from Bluetooth has these what they call services and characteristics, and a characteristic can even have multiple sort of attributes. And these are, I mapped these all out. This is just a straw man sort of ad hoc mapping, but you can see it reuses some of the existing resources. Those are black. Those are well-known resources to be reused. And then we had to add some new resources that we had to define that don't exist in the existing set. And assuming that you would come up with, say, a whole mapping of a vertical, then you would add a set of reusable resources that are needed for that vertical, and they could, if they're useful, they could be shared and reused by other vertical, you know, by vertical I mean a set of people that would get together and say, we all agree to use these objects to represent, you know, our products, for example. So, you know, these are the different things that are there. A more complex one might be this smart thermostat that has basically I took the Nest API and mapped it out. So, you know, it's like you can take any API that the BLE thing is a set of services and characteristics and attributes, and the Nest thing is a JSON. And you can map these things out to IPSO objects and create an IPSO object that would allow you to interact with the Nest thermostat in the same way that you interact with it through its
sure. So let me kind of drill into some of this, because this is really interesting to me, at least, and hopefully I'm not asking stupid questions. But so the resource side, so kind of if I came along and said I want to kind of create a smart object, first thing it looks like is I would need to have a resource ID, and so I get that from OMA, or do I get that from IPSO? And how do I get that?
Okay, so basically there's a space for people to experiment with. So you can just sort of like this 12300 is a space that's unassigned right now and sort of an experimental space. Okay. And so you can do your own, you know, you can basically experiment with your own, create your own IDs. But what you're asking is more, when I want to create a standard and register them, how do I do that? And so currently what we would offer that you could come to the IPSO Smart Object Committee and sort of have a working group that agreed under that venue. That would give you a place to sort of get together and meet or whatever. But that the objects themselves, once everyone agreed, then would be submitted to the OMA for registration.
Okay. So OMA is the register here.
Yeah, they're the name authority. Is the OMNA? It's the OMA name authority. Open Mobile Means.
And so, is there like an automated way to consume all these model descriptions? Is like the OMA serving an online directory or some sort of yellow pages for IPSO?
Very good question. So the tools for managing these are provided by OMA. Currently, there is a single web tool that you can get access to for registration of these, and you create, basically the web tool allows you to enter all of this information, and it creates an XML file format they call a DDF file. Mm-hmm. DDF files are standard OMA files that were even used back in the OMA DM days, and now are also used for lightweight M2M. So you use their tool to create DDF files, and the DDF files are registered. That's where basically the authority is. And yes, you can go to the OMA currently, and you can see the currently registered DDF files for all of the registered IPSO objects. They're on the OMA website.
Interesting. Okay.
The OMA later, sort of on through the end of the year and into next year, we're working with them to create an even more user-developer-friendly set of tools that will allow people to try out objects and to run basically CoAP and lightweight M2M protocols against endpoints, and model objects at endpoints, and basically kind of do more of a developer level tool set. And basically creation and registration of objects will be a little more automated. Currently, you sort of have to have some email dialogue with the person, and I'm sure that will always be the case, but we basically are going to be automating things. The idea is that you can take an existing set of objects, and really this set of objects is on a GitHub right now that I host. It's way out of date. I haven't done the new DDF files yet, but basically go get the DDF files from some GitHub for some set of objects that you like or are close to what you want. You can fork that repository and then use the OMA tool to open them up and make your changes and create your own object set, rewrite the DDF files, do your own sort of validation and consensus management or whatever you need to do, and then register them back with OMA. So that's sort of what the process will be like, a very, very much a fork and test kind of open source oriented process.
And so IPSO is the place where you can collaborate with others to create some instances of these, but OMA is kind of the home for the tools to actually register them and kind of create them.
Exactly. OMA manages the lightweight M2M specification, which is currently 1.1 is being worked on, and they don't really have a venue for hosting these application groups, but IPSO has the venue for hosting these different application groups. The people, the number of people, or if you look at the membership of IPSO, it includes Cisco and Google and people like that. Really a lot of semiconductor vendors that are, as well as application providers, and it's a great venue, and we offer that for people to come in and in the Smart Object Committee and form other committees as needed to basically address the adoption of IP protocols for smart objects. So that's really the broader mission of IPSO, and the Smart Object Committee is to build on these tools that already exist in an application framework.
Interesting, great. So how do you recommend people getting started? Like, what are the steps that you suggest people take, or kind of, did you have some resources that you want to point people to?
Yeah. So here in the same have a set of references, and there's the IPSO Smart Object Guideline. You can go to the IPSO Alliance and download the guideline. It's an open standard. We have the copyright on the document, so you basically download your document there, but it's free download and no intellectual property of any kind, no license. It's basically copyright on the document itself, on the specification, but for using the objects or any way you want, there's no encumbrance at all. And then I've references here to OMA Lightweight M2M. Basically, to get started, I would download the Smart Object Guideline. I download the other stuff or look at it and kind of familiarize with the specifications a little bit. I think on the IPSO website there may be some other material, some explanatory material, and I'm working on creating more of that even as we speak. But so basically, look at that stuff, and then servers are basically, you can use. There's open source servers from Eclipse. You can use
Leshan?
You can use the Leshan server, which is, I don't know if it's an official Eclipse project yet, but it's pretty close, and essentially it's.
Yes, it is in the process of moving to Eclipse. Yeah. But there
And
is
then-
already a public sandbox available. Yeah.
And then for your constrained devices, for a C++ environment, there's the Wakama, which is basically everything you need for constrained devices. So you can, basically this is already a lightweight M2M, working lightweight M2M framework. We offer one at ARM and Mbed as well, a lightweight M2M framework with a C++ client and Mbed and a server.
Yeah.
an embed device server. So you can go either way. In fact, you can use Wakama and embed if you like, and and connect to Lashan, which we do also.
Or the embed servers. We should definitely talk about what ARM's doing in this space too. I don't want to shy away from that. So.
Yeah.
So would it make sense? Like, so I don't know if in kind of in the ARM and so the embed, I forget the platform name for that ARM just announced. Help me out, Michael. What was the name of the IoT platform from ARM that you guys announced?
We call it embed.
Okay.
We've just basically branded the whole thing embed, and we call the device part, the constrained device part, embed OS because it's basically a set of services that have communication, security, and this lightweight M2M library.
Right.
And then the other part, the cloud part, and that's all. Basically, it's open source, but we allow binary libraries as well from vendors. And then the cloud part is Embed Device Server, which is a Java program, but it's a licensed software. We offer it. We offer a developer kit that you can get as jar files that you can run for free. That's slightly limited, but actually is really quite useful and doesn't have any real limitations on protocols or anything. And we offer the Embed Device Server as a sort of sandbox that you can use within Embed if you have an Embed account as well.
So do you like and do you provide, just bringing this back to smart objects, do you provide like samples of the smart objects that people can use with the Embed Device Driver? Or like within Lashan, should we think about providing some examples of smart objects that people could pick up right away, that kind of the XML files that people can pick up right away? Would that make sense? Or?
Well, I don't have yet a way to construct objects from the XML files. That's something that would be a really interesting thing to work on, and I'm kind of thinking about also as a tool that would consume the XML files, or even a JSON file that would be easier, if that would make sense, right? But a tool that would basically take a template and be useful as both a constructor for the embedded library to build objects with, and as a sort of an application level hypermedia template to be able to consume those objects. So that doesn't really exist yet, but what I've done is I'm starting to build some ad hoc demos of some constructed smart object endpoints, and anything that we can offer for people to get started. I'm putting together some resources that I've put together in Embed, but there are some, we should say, some of the standard ones, and then some ad hoc smart object endpoints as well, just to try to experiment with some of the patterns.
All right. This has been really interesting. I've learned a ton. So I think kind of we'll put a link to the Smart Objects page on the recording of this Hangout for sure, so people can easily get to it. Benjamin, you have any other questions?
Yeah, no, I was just wondering if the people who are watching us had questions for Michael. Feel free to use the Q&A, but I haven't seen any questions so far. So yeah, feel free to. I mean, Michael, you're on Twitter, right? If people want to contact you.
Yes. Yeah.
Okay. And actually, Michael and I are talking at a conference next Monday at Moscone in San Francisco. So I'm sure you can track down Michael after his session or during the conference too. So. Well, I think, Michael, this has been great. I've heard lots about smart objects and kind of been following it on the periphery, but I really, frankly, did not spend enough time to really kind of try and understand it. So this definitely helped me a lot. And frankly, I did not realize it was so tightly tied to lightweight M2M. But now I get it. So.
That's the thing. You can basically use your existing lightweight M2M libraries and servers and just start using smart objects immediately. It's just a simple definition. If it's just an extension of what's already there. So that's basically been the benefit for me, is to be able to reuse all of the stuff that already exists. So yeah, please let me know if there are any questions. I'd like to help people get going with this, and I've got some educational materials that we'll be putting up pretty soon also.
Perfect. All right. Well, thank you very much, and it's great chatting. And yeah, thanks again.
All right. Thank you.
Thanks, Michael. Bye.